Aki's presentation was excellent, and it kind of underscores my major theme, which is there's a lot of great things happening around the world, and we need to pay attention to them. This is a presentation on an advanced international distributed programmable environment. In other words, making this environment truly worldwide. And it's called Slice Around the World. This is a term and actually a concept invented by Chip Elliott. We put together a consortium to undertake this, and these are our collaborators because it takes a global community to do this. So a basic goal of this is to create a large-scale distributed environment for basic network science to create a fabric as well as a series of demonstrations. So this is more than the demonstration. In fact, everybody we've talked to said they want this to be a persistent global environment. And so we're designing and implementing an international distributed environment at truly global scale that can be used for next-generation communications and networking. And it's much more than network. As you saw in Aki's demonstration, there's a lot of other things out there that can be integrated, including absolute innovative new things. And the environment is based on interconnections among major network research centers around the world. So most of our consortiums are actually network research centers in different places around the world. And again, the initial concept for this was suggested by Chip. So thank you, Chip, for this inspiration. Motivation is, again, recognition that we have GENI in the US, but European Union has FIRE, and the Japanese have a wonderful initiative called the New Generation Network, some of which you saw there. The Koreans are doing some terrific things. Paul Mueller at GLab is doing great things. So there's a lot going on in the world that we have to connect with. So couple things. One is that this is doing a distributed environment. That's one thing. Another is the demonstrations showcasing that environment. And there are several components to the demonstrations. One is application services, one is the environment, and one is the foundation facilities. And just to acknowledge our collaborators, these are the organizations and the leads for the organizations that we're dealing with. In some of the organizations we're dealing with, there are 20 people working on various aspects of the project. So one of these days we'll have the full list. And then earlier this morning, Rob Ricci threw me a token saying, watch this space in the future, and I'm grabbing that now because part of this is the work he's doing in Utah. Now, as background facility, I want to point to this. This is the global environment. The global Lambda integrated facility. It's a distributed facility. It's not a network within which you can create private networks. So there's many private networks that have been created on this and many test beds. And this is another global community initiative. And this is what we put together to support this demo. It's an international fabric interconnecting a lot of resources in a lot of places, and we will be adding to this. So as Mark said, you'll see more in Houston and other places. Now, I should dedicate this next segment to Glenn Reichert because he's an app guy now. And we, as a community, said we want to do more than just showcase advanced technologies. We want to actually show them doing something. And so these were the criteria that the community came up with. Must have striking visuals, not just digital media, which we've done, been there, done that. It must reflect the potentials of a truly global environment, must closely integrate programmable networking, programmable clouds, show capabilities absolutely not possible with standard networks, not even advanced R&E networks, highlight the power of programmable networks, especially customizable at the edge, and show potential for resolving real issues, solving real problems, not just doing technical stunts. And the selection that we did was a scientific visualization for nanotechnology. And this actually relates to our work here in that we're working with some nanotechnologists that are creating new types of custom materials that are taking functions and components and actually putting them inside fiber optic devices. So in other words, the function that would be in a component is actually built into the fiber. This is creating a viewing scope for invisible objects, objects that can't be seen, and it's based on ad hoc networking, provisioning, and use, including dynamic change in real time, so you can do real-time steering. Demonstrates capabilities not possible. You cannot do this with networks, and maybe I'll have time to talk a little bit about that. And it's customizing the network specific to the application. In other words, the person at the edge, the researcher, in this case nanotechnology researcher, creates dynamically a customized network specifically for his application and changes it in real time as he works with that application. And it resolves a real challenge in that they cannot do this today. They've been doing this through batch processing. So with that, I'll point to this band gap. You can see you can choose this is a virtual instrument. You can choose a light source, a magnitude, a particle size. So you can do optimization of, in this case, a gate array with custom materials. These are some of the resources, and I'm going to turn this over now to Jim to, okay.
Okay. Let me explain a little bit. What we have done is slice using forwarding rules based on the payload content. So it's all the open flow right now is matching the header. This is actually look at the payload, and depends on the content of payload, and we send it to request to different VM around the world.
Content distribution network.
It's yeah, Joe just gave a name. It's a content distribution network. So what you see over here is right now there's probably 10 different sites, 6 different VLAN, and we divide into 2 different set of it. This is one set of it. There's a iCare, and there's with HB Lab, a GENICloud facility, and CNIC in the Chinese Academy of Sciences in China. And it's a Pearl Genie in Utah. It's on this set of resources. And in Germany, Karlsruhe University. On the other set is the University of Essex in England, UK, and the Canary Communication Research Center of Canada, and Sarah Supercomputer Center in Amsterdam, and the University of Victoria, and this is the other side of it. As you can see, there's a different experiment on there, and the NCLT stands for National Center for Learning and Teaching for Nanotechnology and Sciences. So that's a National Science Foundation funded education, learning and teaching center. So we work with the scientists in that group and come up with this real-time rendering for MPI clusters at different places. For this demonstration, we took the front end and put the data in a different VM and scatter that VM around the world. So you can see the different data from different part of the world. Let's see. I have a version which, let me see. Because of network, so this is the data on my network, on my laptop. So this is one of our experiment here is based, what you see here is the light wave going through the band gate. And by turning the band gate and different kind of wavelengths, you will see whether it can penetrate it or not. So this is a future generation of your computer and devices. So researchers basically look at it and say, okay, this will work, it's not work, and the size of a gate, and you can control it. And let me try to go to live. So this is the other version of it. It's a nano particle chain, which is a silver particle, and in reaction of the energy wave hitting on it. So as you can see, there's some drop there, but it's still usable. And here's the other one. Yeah, we can go to a lot of detail about what's nano science behind it, but for interest of time, we just stop here and let you finish.
Yeah, so as we said earlier, we're going to demonstrate this at a variety of different events. We'll be over there at EuroView with Paul Mueller in 2 weeks, and then we're going to also showcase this at the Federated Clouds Workshop in San Jose, at the GLIF Workshop in Chicago in October, and GENI in Houston, supercomputing, and a number of other events. Aki said he has an event in Tokyo that he may want to show this at. And that's the presentation. Thank you very much.